Okay, so we're going to continue our story about graphical presentation of data, and this is now beyond histogram, or should we say something else than a histogram. And I have the number of things I want to point out that are very often done to present data graphically. The first thing it would be time series plots. You can call it also time series diagrams, time series graphs. What is important here is obviously to notice that there is something to do that is something to do with time. So that's why they are called time plots. So very often people call them time plots. Time series plots will be the full name. Okay, here you have an example in which I have attendance in my class over the 10 class session. So the time is not necessarily going to be the continuous time. It could be just like attendance in my class, which would be one class will be Monday and Tuesday, then another week and so on. So it doesn't have to be every day, but it is over a time period. So we have a 10 class sessions, right? Maybe 2 weeks, maybe 3 weeks, maybe 4 weeks over some time period. So in the first class I have 28 students attending. Second class I have 23 students. Third session I have 24 students, and on you go. And when you read the numbers, uh, they don't tell you much. Okay, maybe you can notice there is some difference, of course. But when you make a graph, which you're going to have time on the x-axis, that's the key, right? The x-axis will have a time. And then on the y-axis you will have whatever the feature you're using for the data. Now I'm having here number of students, right? So that's a variable, number of students on a random class session. But I have them ordered, so the first day, second day, and so on. And that's what I'm using for the height, or the y of the point. And then, of course, this is a polygon. It's a line graph. People say line graph. It's a polygon, right? So those points are connected now. So this point I got here would be fifth day. I had 26 students, right? So every column here is a point. Ninth day, I have 22 students. 9, 22. Okay? Well. And you connect them with a line, and it will indicate to you a trend. So you get a trend idea here. What's going on here? Now I can see something which I would not worry about. In the beginning, I have all of my students, most of them. Usually people don't miss the first session because they want to get some information. Some people do, but most of the people don't miss the first session. But then it drops off a little bit, and then keeps on dropping further a little bit. So this is the kind of the things I see regularly in my classes. I have usually, maybe I could say, the second session would maybe usually in my class is a little more students than the first session, but then it keeps on dropping off. Some people just stop attending, some people drop, and so on. So this kind of trend that I'm reading here is not going to worry me. Okay, I'm gonna say, oh, okay, this is what I usually get. Okay. For example, if you look at the, I'll show you another trend that is something that obviously should be a little bit worrisome. When you look at the infections in the United States, and in particular, I might be interested in New York, then obviously you're going to make some kind of time series plot. It could be a vertical bar graph, so I use the bars instead of the just points, but it's still time series plot. So I have here something like in the state of New York up to yesterday, which was the December 28th of 2019. A really bad year for the New York, and I'm looking at number of things here. For example, a worrisome time series plot here, New York hospitalization, the state of New York from Sunday, August 7th, that's through the summer. We had it very, very nice. And then in November, we can see this going up and up and up and up and up. And the December 28th, we have a 7,559 hospitalized people. Bad number to look at. Okay, so this is a time series plot, which is a kind of hybrid because I have actually vertical bars. So I could have just used points, but this is kind of nicer because you can have, better graphics that way. I'm just saying this is another type of a time series diagram, time series plot. This one is with the bars as opposed to points. Okay? So that's one type of a time series plot. Another type of a diagram, another type of a chart, time series plot. Okay? We also have all sorts of different vertical and horizontal bar graphs. So for example, here is another one. Again, this is the this one is definitely not a histogram. Apparently you can see the gaps here, right? And it's not time series plot either, because down there I have the ages of the people voting for either Clinton or Trump. So this is the age distribution during the 2016 election. Maybe I should use 2020. We still don't have complete data for that, so once we get that, I'm probably get that. But it gives you an idea who is voting for whom, right? So we have the youngest age group, 18 to 24. Something like 57% is voting for Clinton, and 35% was voting for Donald Trump. And then as the age group increases, then we have the people more voting for Trump than for Clinton. So it's kind of giving you some idea about the data. This is a vertical bar graph. It's not a histogram. It's definitely not a time series because you don't have time down there. It's another type of a bar graph that we use to get some comparison, right? So this is a comparative graph, right? So you have the vote for Trump, vote for Clinton in this particular age group. So it gives you some idea what's going on in terms of age group and the elections 2016. Okay, another one that we use very often, vertical bar graph, that we use very often is Pareto bar graph. Okay, now Pareto bar graph is usually organized in the increasing or decreasing fashion, which means that we put the tallest class first, and then the next one, and the next one, and so on. The bars are done that way. Okay, so here I have the 2020 estimate by International Monetary Fund in terms of a GDP per capita, and also it was done by using the power purchasing parity, meaning that you're not just looking GDP per capita, but gross domestic product per capita, but you're also using what people in those countries can buy with that kind of money. So it's adjusted, not a raw GDP per capita. So we see that in Qatar, this is in the Persian Gulf, country in the Persian oil-rich country in the Persian Gulf, small country. They have $138,910 GDP per capita, significantly more than the United States, for example. Macau, that's a little gambling city in the coastal area of China. Then Luxembourg, a small country in Europe, banking asylum, that people go there to bank, to keep money in the bank without getting, like Switzerland, without getting data public to some kind, not public, but to accessible to some some kind of taxing authority, right? Uh, Singapore, another city-state in the south of the Indochina. Ireland, 86,988. Maybe I should get a job in Ireland, right? Brunei, oil-rich country in the Indonesia, not Indonesia, but one smaller country there. Norway, you know what that is, in north of Europe, right? The United Arab Emirates, Kuwait, two countries in the Gulf, Persian Gulf. Switzerland, again, a banking country which apparently have a pretty good GDP per capita. And then United States. We are not really all that high as we think we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are 11th. Okay, then Hong Kong. That's another city-state in the coastal area of China, a part of China nowadays. Okay, so if you want to present this data as a Pareto graph, this is how it's going to look like. Okay, so this is a typical feature of Pareto graph. First, of course, you're going to have vertical bar graphs. Vertical bar graph. But the data is ordered. The data is sorted, meaning that you have the tallest bar. Sometimes it's done the smallest to the tallest, but this is usually done from the tallest to the smallest. So you have the vertical bar graph for the highest GDP per capita, and then you have the next one, and then you have the next one, and on you go. So you get some kind of idea about the relations. So you can say that apparently it looks to me like, you know, the people in Qatar have twice higher GDP per capita than people in Hong Kong or in the United States. And we have a little more than Hong Kong. And Switzerland has a little more than we do, and so on, right? So it gives you a comparative idea. So for example, if I want to present your test scores to you, I would do that, okay? With the exception that I would not write your names down there on the bottom. The names in the vertical bar graphs, that is a Pareto graph, are usually put down here, right? The names of the classes. So this is a class for Qatar bar, for Macau bar, for Luxembourg, and so on. So the names are usually put like this. So if I do that and I do your scores, I would probably put the tallest graph, the tallest bar score for the best student on a particular test, and then the next student, and then the next students, and then the next students. I used to do that just to show you, I'll give you an idea where you are. So you can say, oh, I'm here. Oh, that doesn't look good because there are so many better than me. But I usually don't put the names here. I put student number 1, number 2, and so on, rather than names, right? That would be full information. You would know who is better and how much. So that is a Pareto graph. Very often done. So the essential feature of Pareto graph is sorting. So it's not at random here. This is the biggest Y, the biggest income, the biggest GDP per capita, power purchasing parity. Then the next one, then the next, and so on. And then the lowest here. It could be in reverse. It could be from the smallest to the tallest. That is done as well. Okay, pie charts. Circle charts are often called pie charts. People usually call them pie charts, pie graphs, circle graphs, pie diagrams. Very often done. So I have here a group of 20 students, calculus test, one of the calculus tests. The first student has score of 77. 77 is probably percent. The next one, yeah, it says percent. 32%, the next one 56%, the next one 97%, and on you go. Yes, you could make a histogram here, but you really want to have an idea about the grades. So since the grades are, as I explained it during the story about a histogram, are separated into classes that are not of the same width. A grade is between 90 and 100. That's the width of a class. The B grade is between 80 and 89. So it's already a little shorter. And of course, F grade is between 0 and 59%. So that is the longest, the biggest range of all of the classes. So that would not fit as a histogram. You will have to do something else. But I'm interested in grades here, right? So I'm separating based on grades. So the A's are the people in 90s, so I have one here, and I have another one here, and another one here, and another one here. Four A's. B's are people in 80s, so I have 80 scores, I should say. 85, 2 only. C, 77, 76, 73, 79, 4, 77, 5, and another one here, 6. 6 C's. D's. Don't see anything in the first line. I have one here. 67, 1 D. And the rest is all F. Lots of F. F. 7 students have F scored. They're not all the same, of course. 56 is a lot better score than 32. But these are all Fs. And I have 7 of them. Okay? So now I have divided my classes. And again, I didn't do histogram here. I divided it based on grades. I'm aware this is not a histogram. So I'm making a pie chart. So this is the F grade. I put the color coding here on the side. This is like a guide. And I have 7 here. This is sometimes done. Then I have the, I think this is B. Let me check. Yeah, it says here C actually. All right. And I had 6 in C. Then I have, this is B. And only 2 B's. Okay. I have A here, and I said before I have 4 A's. This much notation is not needed. You might want to do that, but it's not necessarily something that is required for pie chart. Pie chart doesn't have rules, so you can do all sorts of different things. Some people do that 3-dimensional, like a cake. You can see it very often in USA Today if you ever get that paper. So this is one only. Okay. What's the key here? The key is that this ought to be proportional. So when you're talking about C and compare C and D, D has 1 item, C has 6. This slice had to be 6 times bigger than this one here. So you have to assume some kind of proportion. Proportionality is based on area, of course, right? So you have 20 students here. 20 students. A has 4 students, or should I say scores. 4 out of 20 is 20%, which means that this slice ought to be 20% of the whole cake, right? The whole circle. So you have to make sure that that is exactly what's going to happen. Okay? This one ought to be half of A. This one ought to be half of B. A and B combined, 6, had to be as big as C. Or should I say it in reverse? C has to be as big as A and B combined. And this guy had to be as big as C and D combined. So you're going to have to measure. You might want to use a compass, right? Now, if you don't have the proportionality, if this is not done proportionally, you can do it with a computer. You can do it with Microsoft Excel. But if it's not done proportionally, then it's not a pie chart. Then it's just some kind of doodle, right? So it's very important the graphic representation is not a doodle. It had to be proportional. It had to be done in a precise way because you want to have some idea. So when I look at that, I'll be, oh, I don't like this at all. I have so many F's. I don't have so many F's, right? I have many C's. Oh, I'm not surprised with that. That usually happens. I have some A's. Okay, I'm okay with that. I have B's here. I have this. I'm worried about this, right? I have too many F's and not many D's. So how come that these guys are not getting at least few of them D's? And I'm probably gonna look at that and I'm gonna say, ooh, I have the 56 and 55 and 55, this and 57 and 55. 5 people get almost to the D, but not quite. Maybe I wanna curve my exam, right? So I'm gonna look at that kind of thing. I'm not gonna be happy with this kind of distribution here, right? So again, pie graph. Essential feature of a pie graph, proportional slices based on the area. So again, A and B combined are 6 scores. C, 6 scores. This and this must be the same area. Okay, some people also don't know what the center is, right? So make sure that all of the slices are starting in the center, right? They have to have vertex in the center, not here. I've seen sometimes when I get the exam, people do stuff like that. That's not a pie chart, it's a doodle, right? So we don't want to have anything like that. There ought to be some kind of presentation that makes sense. Okay, I want to talk a little more about the stem and leaf display because I said during the histogram lecture that the stem and leaf display is going to be a way to sort the data. Okay, which means you can use this if you don't have a computer. If you don't have a computer to sort it for you, like Microsoft Excel can sort the data, then you have to do it yourself. And one of the ways to do that is by using a stem and leaf display. Technically, stem and leaf display is not a graphical display because it doesn't really have any drawings. Okay, but in essence it is, because you really have a graphical presentation of the data that you can look, and then you can get some idea about the distribution by using perception, visual perception. So there is a visual perception here. This is a finished stem and leaf display. Okay, so what I'm doing here, I'm using that sample of Hawaii Airport, right? Sample is not ordered, so I don't have the things in the order. Okay, so I would like to make a stem and leaf display of this sample that will also help me to order the data. So how is that done? Well, first of all, you're going to divide this into classes. You can use tens, as in single digits, then 10 to 19, then 20 to 29, 30 to 39, 40 to 49, and we already know that we have something in 50s here, and that's it. So this is how it's done. You would use the vertical bar, and then you would divide that into stems. Just what I said, the stems are going to be in terms of tens. Single digits, tens, 20s, 30s, 40s, and the last one, 50s. Now notice I left the header out. Put a double bar here, or a ticker line if you like. This is the guide. And so I'm gonna write one piece of data I have here, 41, 4, 1. and I'm gonna add something here like as in £41. You might have a little more explanation. The idea is £41. Maybe I should write pounds because this looks like a number, right? So I'll just write pounds. Maybe even more. Pounds of weight, of luggage. P-U-N-D-S. Okay? So this ought to be clear what's going to be in this table to a person with a reasonable IQ. 41 as in 41 pounds of weight of luggage. And then you are going to be sorting the data, tallying the data the way you would do whenever you're tallying something. So 30 27 1242 12 42 35 47 and on you go. Okay, I'm not going to do all of that, but this is what's going to happen. Eventually, when you tally on everything, so you go one by one and just keep on listing them here. What is very important here is that the data is aligned, so there are columns here. Okay, because if you don't have them aligned, if they're not positioned properly, you will not have a visual presentation. You will have a listed numbers, but you will not have a visual presentation. You can still have that sorting done properly, but you won't have idea about the division of the weight in terms of tenths of pounds, and so you will lose the visual presentation to even to you're going to have a sort. So this is two things: you're sorting, you're also visually presenting. Okay, so now you have the everything separated into classes, but it's not sorted. So you have a 3 and 0. So 3 is before 0. It would be in reverse, right? You have 12, 17, 18, 19, and 12. And then 18, 18. Okay, so you have to sort this. Now it's much easier to sort now because it's a much smaller amount to sort. So you have 0, 3. You're going to have here 2, 2, 7, 8, 8, 8, 9. It's very easy to sort a single digit number, right? And on you go. Again, this piece would be usually called leaves, right? So this is a leaf, a leaf, a leaf, a leaf, a leaf, and so on. This is usually called stems, right? That's why we call this stem and leaf display. Okay, so this is not a stem and leaf display yet. It isn't sorted. Okay, but once you sort it, so it's going to be 0, 3. In the first one, I said already, the second one is going to be 2, 2, then 8, 8, 8. Oh, excuse me, 7, then 8, 8, 8, then 9. 2, 2, 7, 8, 8, 8, 9. The next one, it's easy to sort. You have any zeros? Nope. You have any ones? 3 of them. 3. You have any 2s here? 1, 2. You have any 3s? Nope. You have any 4? No. No 5 either. But you have 6. 1 here and 1 here. 2 6s. And then you have some 7s here. 1, 2. That's it. 2, 7. 8. Single 8 here. And 2 9s. 9, 9. 8, 9, 9. Finally, you have the data sorted. Now you have the what we call stem and leaf display. This is a stem and leaf display. So again, it had to have a visual quality. This is a visual presentation. You can see this class in 30 is the biggest, the modal class here. Modal class, M-O-D-A-L, the largest class, the class with the most amount of the data from the sample. And then the next one here. So most of the people are carrying either something in 20s or 30s pounds of luggage. Okay? And then of course I have this class, then I have this class, then I have this class, then I have this class. So I have the visual presentation. And the visual presentation is achieved by alignment. Again, if you don't have an alignment, if you have these two and then you have a three squeezed into the same width, then you lose the visual presentation. So that's a problem. And people often people when they do stem and leaf display, they make that kind of mistake. That would not be stem and leaf display. It's just be some kind of sorting routine. You also have a sorting here. You can clearly see that. You can read this. 0, 3, 12, 12, 17, 18, 18, 18, 9, 21, 22, 20, 21, 21, 21, 22, 26, and on you go. So you get this sorting too. So sorting is done in an easier way than if you go one by one from the sample. You first divide it into classes, which is much easier to tally, and then you are sorting the class, which is very easy to do because you have a single digit number to sort. You could also have this split. You might want to have 0, 0. Sometimes that is done that way. So stem and leaf display could have like, so there is a header here, so I'm going to write that. Then you have a 0, and then the next class would be, if there's lots of data, 0. And then the next class would be 1, and then the next class would be 1. What does that mean? Well, this is going to be stuff between 0 and 4. This stuff will be between 5 and 9. Okay? That's the idea. So you want to split that. That would be actually a pretty good idea to do here for these three classes because too many things in it. However, this class doesn't need that and this class doesn't need that. So it's your choice. But if you do it for 3 and 3, you need to have 4 and 4 and 5 and 5 and 2 and 2, 1 and 1 and 0 and 0. So you have to split for every class. Otherwise, you're going to have bias, right? You're going to split one range between 20 and 30 into two different ranges, between 20 and 24, between 25 and 29, while you won't split, let's say, 10 or something like that. So if you use this approach, then you have to do it for every class. So it's going to be for 20, you have 2 in 20, so you're going to have 20 to 24 and 25 to 29, and on you go for every one of them. You could also use 2 digits. Sometimes you have, you have like hundreds. So you might want to use tens, like 10, and then there will be 100, 101, 102, 103, 104, and so on. So again, this stem and leaf display has 2 essential things about it. Number 1, it is visual presentation. Number 2, it is a sorting routine. Okay, so both of those had to be. It has to be sorted, which means that this is not a stem and leaf display, and it has to also have a visual presentation. This one does have a visual presentation of the data in different classes. Okay, stem and leaf display. Okay, now I mentioned in the histogram lecture that we do have the calculator we can use for this purpose. Okay, and I was a little bit fast on that, so I'm gonna show you that now by using the TI-84 calculator. So TI-84, you can have TI-83, TI-84 Plus, which is actually says TI-84 Plus C Silver Edition. It's actually software on my computer, but you might have this calculator. Okay, one of the things that you want to do with a calculator that has been used so many times before, you might have all sorts of different things on it that you don't want to have, that might actually impede you from working properly. So I want to use the clearing of the memory. So you can use second here, the blue option is second here, memory, and there are lots of different things you can do here. You can clear all of the entries, you can clear all of the list, you can clear, you can just reset everything. That's just simply going to give you everything clean to the default of the manufacturers. So I'm going to just clear the random access memory. I'm going to clear the RAM, which will clear all of the list. I'm not going to go back to default. I forgot. I might lose something that I did myself. So I'm just going to clear all of the random access memory. Of course, it will ask you, do you really want to do that, right? Because if you really want to do that, you might lose something that you might have there. So it's up to you to choose that second time around. If your calculator is faulty, this might mess up your calculator. Mine is okay, because of course I have, software on a computer. It's not really a calculator. And it tells you, yeah, we did it. Okay, well, let's go back to stats. Button stats, 3 options: edit, calculate, tests. We're gonna mostly do the first two. Down there toward the end of our course, we're gonna do some testing. So the first two. The option edit is what we're gonna do now. Enter the option. Completely clean lists. I don't have anything in the list, right? That's what I accomplished by resetting the memory. So let's use, I don't know, maybe this. It's a relatively small amount, so I can do it relatively fast. Students' grades on a calculus test. I should say scores rather than grades. 77. It says list 1, the item number 1. You might want to go to the list. You have to enter. Now you can do that. Don't delete the list though. If you delete the list, you're gonna have a problem. So for the list, clear. Enter. So let's use list 2 just for fun. 77. Enter. 32. 56. 97. You have to be careful. 55. Uh-oh, I already made a mistake. Okay, so I have 76. 82, 90, 70, 32. 82, 90, 70, 32. It always tells you what you're doing here. List 2, item number 10 is 32. Okay. 10 more. 79, 55, 67, 95. 55, 67, 95. 90, 57, 77. 90, 57, 77. 55, 85, 70. 55, 85, 70. Okay, so now I see down there at the bottom, he expects me to put 21st item into the list 2. I'm not going to do that because I don't have anything else. 20 students, I'm done. Okay, all of the data is in. Now, you can do a number of different things with this data. And we're going to be doing lots of stuff. But for now, we are only interested in sorting. Okay, so you highlight the list over there on so you use the arrows to move around. You highlight the list, it will tell you what is in the list. You can read. Okay. All right. Start moving the list. So I would like to get to see all of this. I really don't know. I forgot how to see that. Anyway, so you have the stuff here. that is in your sample. If you want to sort this, you go back to the bottom stats, and now we were editing, we were putting the stuff in. Now you can do sort in ascending order from the smallest till the biggest, in descending order from the biggest to the smallest. You can clear the list. Then you have to put up this is a instruction, but you have to also put up which list, list 1, list 2, and so on. And you can set up editor if you want to add some more lists there over there. We're not gonna bother with that. So let's say I want to have these in ascending order. All you have to do is to select that. This is in the list 2, so you have to use second here. List 2 is the blue option on the button 2. You have to close the parentheses. Now if you want to order another list, you can just put a comma, and then you can use, I don't know, list 3, which I don't have anything there, so there's nothing going to be sorted there. So you can sort multiple lists that way. Enter. Uh-oh, it's going to tell me, hey, you have a problem there because you have the nothing in the list 2. Okay, let's, so, okay, quit. Okay, error. So it doesn't like that. I have nothing in the list 3. Okay, let's go back to the list 3. Let's put something in it, like something that's meaningful to sort. 8 and 9, right? It's already sorted. Maybe I put, instead of 8 and 9, 8 and 5, just to give some work to my calculator. Now I can do the same thing. Sort. List 2, comma, list 3. Uh-oh, it's complaining about it. Okay, so maybe I don't know how to use this, right? So I'm gonna just do the sorting of one list. Oh, I understand. It has to, it's an optional sorting is list 3 had to be connected with list 2, so I have to have the same number of items. Okay, I'm not gonna do that now. I'm gonna write edit again. I'm gonna clear this list. I don't need anything else. I'm gonna sort the list 2. Okay, stats, sort in ascending order, list 2, close the bracket, enter. It says done, which means now I have to have sorted list. Let's check. Yeah, 32 is the lowest score. I have another 32. Do I have really 2 students with 32? One here and one here. Yeah, I didn't even notice that. And then I have 55, 55, 55, 3 of them. You can see, notice that. You can scroll again to see all of that. Nice. Okay, you can do some basic calculation. Let's see, calculate one variable stats. We'll talk about that a little more. List, we want to have list 2. There's nothing in the list 1, right? Frequency list, I don't have any frequency list. Calculate. Give me the average, the mean, we'll talk about it later. It tells me the minimum is 32, I already know that. And the maximum is 97. There's some other things here. So calculates all sorts of different things. We'll talk about it, okay? So again, if you have some data that repeats often, like you see that, I don't know, 32 happens twice. So I have 32 and it's twice. So I want to write it this way, okay? And then 55 3 times. And so you're going to have to delete this, right? 132, delete. 255s, delete. 56 happens to be only once. 57 only once. 67 only once. 70 happens to be twice. so I'm gonna delete 1. 76 happens to be only once. 77 happens to be twice. So I'm gonna delete this. 79 on 82 once. 85. I have to go back to see that. Is there any more 85s here? No, it's only once. So I have 85 once. 90 I have twice. Okay, I'm gonna have to delete 1. 95 I have once, and 97 I have once. What you have here in the list 3 is a frequency list. So you have data here in the list 2, all of the data, but written only once. So 55 is only once. But in the list 2 frequency, you were listed 3 as 3 times for 55. Okay, so when you do something like that and you want to do some kind of calculation, then you're gonna do the data list 2, the frequency list for that data, and you have to align, so which means they have to be the same number in the first and the second list. I have that in the list 3, and now you can do this kind of calculation. What's the difference between this and before? Nothing. In terms of a calculation that you're gonna get, you're gonna have the same calculation. The kick is that this is a little more organized, because if you have a huge amount of data, for example, larger, big sample in which you have some numbers repeating very, very often, you might want to do stuff like that. It's a little bit more organized, so you have less to write. Instead of writing, I don't know, you might have a 55 30 times, right? So instead of write 55 55 55 55 55 55, you're just going to write 55, and then in the frequency list you're going to put in the same row 30. That means that 55 is 30 times in your sample. So that's what it's for. Okay, again, I'm giving you some idea that this is definitely going to be an easier way to sort than using a stem and leaf display. Of course, stem and leaf display you can use for sorting, but it's nicest to have a calculator. Okay, you can also use Microsoft Excel for sorting. So for example, you can put in Microsoft Excel. This is a Microsoft Office, part of Microsoft Office Excel. You can download. You can get it from the school for free. So something like that. Okay. So I want to sort this. So I wrote the data here. It's easier to write in a calculator, of course. And I can do the sort and filter. Smallest to the largest. Look at that. Done instantly. 2, 2, 3, 4, 6, 7, 8. You can do it in reverse. Largest to the smallest. Done again. 8, 7, 6, 4, 3, 2, 2. Okay. That's another way to sort the data. So you will see in some of your homework problems, it'll give you an option to download the Microsoft Excel file. You have a data, you can download the file, and then you can use Microsoft Excel to sort it, if you have it, of course. Right? You can also do all sorts of calculations. So for example, sum, right? You have to select an extra cell, and then you do the sum. So I select the extra cell down there, and then you do the sum. I'll tell you 32. The total is 32. Microsoft Excel actually rather smart. Okay, so even if you don't select an extra cell, it will also sum it. But it will sum it and maybe put it somewhere where you don't want it. Maybe you want it, I don't know, maybe you want it here. If you want it here, then you're going to write, what do you want to have here? and you have to use a formula. You have to do the sum, and now it's going to tell you where do you select those numbers. Here, and you're done. Right, number 2, okay, I don't need anything better, and it gives me 32, right? Another way to write it would be this. I'm not going really to teach you much about Excel, but that's another way that you can use it. The reason why I'm pointing this out, because you will see in your homework, all of the data that is given is usually downloadable as an Excel file, which means you can open in the Microsoft Excel, so you can do some of the stuff in Microsoft Excel. One of the things you probably want to do with the data is to sort it, and that's a very easy thing to do. Again, if you want to sort this data, for example, all you have to do is to select sort, whatever you want to sort it, largest to the smallest. 32 will come up first. Uh-oh, it gives me the reference because I have a formula here, of course. Sorry about that. So if I have 32, that would be a data rather than a formula. So then I would have it this way. Now if you want to sort it in the ascending order, I will start with 2 and 32 will be the last, right? Okay, so you might want to use the Microsoft Excel if you have it. I would suggest to get the TI calculator anyway, TI-83, TI-84, because TI calculator has a certain scientific calculation features that Microsoft Excel does not have, or have is hidden somewhere when it's going to be really difficult to use it, while the graphing calculator had, you know, better access to calculation features, scientific calculations. Scientific calculator is better than Excel. So it's up to you. I know that this is used in the New York State's high school and elementary schools as an official calculator, at TI-83 I believe. And so you can rent it, you can borrow it from your brother or younger sister if you have. You can, I don't know, buy it if you want to take some more science classes, because you will need it. Or you can get a software on the well, you really need to purchase that to get a software so you can use it on a computer like I have it. One of those options, you can purchase it off eBay, the used one. Make sure that nobody cheats you and don't get some defective ones though. Okay, so that's my lecture for the today, and you can watch this anytime you want. I am going to end the lecture now. So I'll see you next time.